Ooh, here we go. Second half of chapter 7, angle addition, subtraction for sine, cosine, and tangent. Oh, it's going to be awesome. So in this part here, we're going to be dealing with angles that are not our 30, 45, 60 degree reference angles, right? Or our quadrantals. However, we are going to be using those to solve, okay, and to simplify. So inside the sine, cosine, or tangent function is not going to be a nice one, but we're going to use our nice angles with it. So first off, no calculators here, all right? Let's put the calculators away. I'm always strapped with the TI-84, YORO, but I'm setting it aside today, okay? Let's go with this. So when we're adding and subtracting, can we just like straight up do it? Well, cosine of 90 equals then cosine of 30 plus cosine of 60, right? If we could just straight up add them like that, that would hold true. Well, let's see here. Cosine of 90 is 0, right? That's my first quadrantal, x coordinate. Cosine of 30, well, that would be root 3 over 2, and then cosine of 60 would be 1/2. Whether you're using special right triangles or your unit circle, whatever, I don't care. As long as you're getting that. And guess what? Not equal. So that's going to be false. So what the heck do we do then? Well, let's take a look down here. So angle addition and subtraction formulas are as follows, okay? So for sine of some angle plus some angle, alpha plus beta, I would have sine of alpha, cosine of beta plus cosine of alpha, sine of beta, and then it switches to subtraction in the second one. For cosine, you see we have cosine of alpha, cosine of beta, and then it's minus when it's the sum formula, sine of alpha, sine of beta, and vice versa. Now, we can also write these as like a combo, as we see there. So the plus minus, I've got it right there, and then it's minus plus, right? Because the sign changes there for the second one. Okay. So the A and B, the alpha and beta, those are going to be, your nice 30, 45 and 60 degree references, or even our quadrantals, that will make up the angle that we have. So for example, if I had, say, sine of, how about 105? Now, that's not a nice reference, right? That's not a 30, a 45, or a 60 degree reference, but I could break this into, say, 60 plus 45. And then I can expand it into that formula. Now I have 60 and 45 that I'm going to work with, okay? That's what we're getting at with here. We're going to do a couple examples here, but definitely either have your unit circle in the cabeza there, or be ready to work with your special right triangles in your head. We're going to be doing a lot of evaluating here in each formula, okay? So finding exact values of the trig functions, and we're also going to simplify expressions to obtain other identities. It's going to be awesome. All right, to start, disclaimer. Some of these can be done in many different ways. Sometimes there's only, one good way to do it, but generally multitude of ways. So evaluate as an exact value cosine of 195. Yeah, I could plug this into my calculator and get an approximation, but to get an exact one, I'm going to do it by hand. So what two numbers will add to 195 that are nice ones? Well, it's got to have a 45 reference, right? So how about 135? Okay, well, 135 plus what would give me 195? That would be 60. So I'll do cosine of 135 plus 60. That gives me 195, right? Awesome. Fantastic. Now with my cosine sum formula, I'd have the cosine of the first angle, 135, times the cosine of the second angle, and then it's minus, remember from the formula, right? We had our expansion there. We're using this one right here. Okay, so my alpha, my beta, and then minus, then we have sine of alpha and sine of beta. So sine of 135 and sine of 60, right? This is my alpha, that's my beta. Okay? Now we're just going to evaluate all four of these. Fun stuff. So cosine of 135, that's a 45 reference, so it's root 2 over 2, but it's in the second quadrant, so it's negative. Be very careful with these. Easy to make mistakes. Cosine of 60. I believe didn't we just do that? Yes, we did. That was 1/2. And then minus, and then sine of 135, that's positive in the second quadrant. And then sine of 60 would be root 3 over 2. Okay, so I'm going to have negative root 2 over 2 minus, looks like over 4. Oh! And then minus root 6 over 4. And then when I put these together, I get negative root 2 minus root 6 all over 4. I like it. If you had done it in a different way, you may have ended up with, say, negative root 6 minus root 2 over 4. It just depends. So there's a lot of different ways of these going down. So if you pick two other angles to go with, eventually you'll get to the same thing, but your journey there will look a little bit different. Okay, let's try another one. I'll go blue on this one. So now I have evaluate as an exact value sine of negative 165. So negative 165. Okay, two numbers that either add or subtract to negative 165. So let's see here. I could do like 60 minus 225. That could work. I could do negative 120 and minus 45, not 44. Okay. So either one of those would be fine. I'm going to go with the first one here. Let's do it. Sounds fun. All right. So what I have here is sine. I'm going to write it down. 60 minus 225. So I'm using the sine and I'm using subtraction here. So we got to remember that our alpha here is 60, but our beta, that's 225, not negative 225, because I'm using the subtraction formula. If I did negative 225 with the subtraction formula, then I would be doing two negatives there, and that would cancel it out, right? We don't want that. All right, so let's go ahead and expand this. So I'm going to have sine of 60 cosine of 225 minus cosine of 60 sine of 225, right? The alpha and the beta are both positive here. Lovely, wonderful, fantastic. And as we know with the sine formula, it's going to be subtraction. They match up. All right, so sine of 60, that would be root 3 over 2. Cosine of 225, that is going to be a negative root 2 over 2 minus. And then cosine of 60, that's 1/2. And then sine of 225, that's going to be negative root 2 over 2 as well. Cool. Awesome. And you'll start to notice some patterns, like when you have sine of 60 and cosine of 60, you're going to get the, the root 3 over 2 and the 1/2. You're going to see those kinds of things happening. All right. So I have negative root 6 over 4 and then, minus, and then that's a negative root 2 over 4. So that's going to become positive there. And I'll end with, so I don't go into the next problem space there. I'll have negative root 6 plus root 2 all over 4. Awesome sauce. And you'll see there's a notes key likely posted online. They went the other route with that, so I decided to they went this route and got the same answer. Okay. So I figured I would do a different one here in the video. Lovely. You're going to see a lot of these root 6s, root 2s, 4s. It's just how all these nice trig values end up working out when they're multiplied together. So if you're seeing something like that, good stuff. Good stuff. All right. And if you were actually plug that into your calculator, and you were to plug sine of negative 165 into your calculator, the decimals would be equivalent. Okay, you would see that. Awesome sauce. Something a little bit different. Something a little bit different now. Simplify. So here we're going like a little bit, almost like backwards. Okay, so which formula goes sine cosine minus cosine sine? That would be my sine difference, my sine subtraction where I have two angles. Okay, so this is my alpha. This is my beta, right? This is my alpha, my beta. So this is my sine of, I don't know why I'm writing it up here. This is my sine of alpha minus beta. So what I'd have then is sine of I don't know why I just put an S. Sine of 20 minus 15, which is sine of 5 degrees. There we go. So we just leave it as that. That's it. All right. We're basically putting it back together. This is the expanded form. We're putting it back together. Here I have cosine, cosine minus sine, sine. So this is my cosine sum formula, right? It's an opposite sign in there. So this is my alpha. This is my beta. So I'm going to have cosine of pi over 4 plus pi over 4. So that's cosine. Well, pi over 4 plus pi over 4, that gives me pi over 2, right? Right, 2 pi over 4, which is pi over 2. And what is cosine of pi over 2? That's my first quadrantal. That is 0. So there's my final answer. I will box that, otherwise it's circled. That looks weird. All right, very good. Wonderful stuff. Wonderful stuff. I like it. Yeah. All right, last one here. So sine of 1 degree times cosine of 2. So sine, cosine, cosine, sine. This looks like sine sum. All right, so sine. Hold on, I'll do my alpha and my beta, right? Alpha, beta. So this is sine alpha plus beta. It's getting a little crowded over there. I'll write it down here now. So I'd have sine of 1 plus 2, sine of 3 degrees. Awesome. Fantastic. I'll even put a little degree marking up on top there so we don't think it's radians because it's not marked. Coolio. I like it. Good stuff. Fantastic stuff, in fact. Huge fan of these, if you couldn't tell. Proof that is. All right, here we go. So, want to prove that cosine of negative pi over 2 minus x is equal to negative sine of x. So what we can do here is we can use our cosine difference formula, okay, and expand it, and let's see if it simplifies down. So if I were to do that, I'd have cosine of negative pi over 2 times the cosine, right, of x plus, right, it's the opposite sign here, sine of negative pi over 2 sine of x. We want to show that that equals negative sine of x. Remember, we're not going to manipulate the right-hand side. We're going to only do one side, the more complicated side. Well, cosine of negative pi over 2, that's the quadrantal down here, right, at negative 90 or negative pi over 2. That would be a 0 times cosine of x plus, and then sine of negative pi over 2, that's negative 1. And then sine of x. So this is gone, leaving me with only negative sine. Oh my goodness gracious, would you look at that? Mic drop. If I had a mic to drop, I would drop it at this instant because that was dope. Okay? I hope you enjoyed that as much as I did there. Love when things work out and just cancel. So cool. So cool. All right. Let's keep moving. Oh my Lanta, what do we have here? We've got, suppose that sine of alpha is equal to 4 over 5 and sine of beta is equal to 5 over 13, where alpha is in that first quadrant and beta is in the second quadrant. I like to read it like that rather than read it all the way off. I'm just like, okay, first quadrant, second quadrant. So, you know what I'm going to do? I'm going to draw some triangles because these aren't normal trig values, nice trig values. But let's go ahead and draw some up here. So in the first quadrant, this is my alpha. And sine is opposite over hypotenuse, and I remember honors geometry because I've taught it for 9 years. That's a 3, 4, 5 triangle. And then I'll go with a different color because I'm awesome like that. We're going to go red. All right, and in the second quadrant, this is my beta, and I'm going to have sine is opposite again over hypotenuse. That's a 5, 12, 13 triangle. Whoop, whoop. Cool. I like it. Awesome. Fantastic. Wonderful. Hold the phone. Negative 12. Why didn't anybody speak up? Why did you say, yo, Mr. Allen, you forgot a negative sign? That would have been terrible. Okay, so now we want to find cosine, change the color again, alpha plus beta. Okay, so let's expand this, and I'm going to write that down here. Expanding that would be cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Okay, that's my expanded version of this. And now all I'm going to do is I'm going to take the various values for cosine of alpha, which would be adjacent over hypotenuse, cosine of beta, which would be adjacent over hypotenuse, and subtract sine of alpha, opposite over adjacent. Well, I guess I already have that too, and then 5 over 13. So really I was using the triangles to get my cosines, right? And now I can multiply this together, and some of these numbers, might get a little bit large, but you guys can handle it. So I get negative 36 over, that's what, 65, and then minus 20 over 65. We can combine those, and then I've got negative 36 minus 20, that's negative 56 over 65. And I think we're done there. And that matches this key. I like making sure that I don't make mistakes in these videos. So I got it keyed up too on my other laptop. And we nailed it. America. Fun story. Kid in high school, after he tried out for the musical, everyone asked, hey, how did it go? And he went, nailed it. Apparently he did because he got the lead, but it was, who does that? All right. Let's continue. Simplify the expression. Ooh. This looks like a bear. My goodness. Sometimes we just gotta take a leap of faith here. And I'm thinking, perhaps, if I were to expand the numerator, okay, I mean really expand this bad boy, perhaps I can group some things can cancel out. Let's see what happens here as I expand it. And just to keep things fresh and exciting, I'm going to change colors. Okay, so for my first expansion here, I'm going to have sine of alpha cosine of beta plus cosine of alpha sine of beta plus now my second expansion, and maybe I'll change colors for that so we can see like the difference. We'd have sine of alpha cosine of beta minus cosine of alpha sine of beta. There we go. All over cosine of alpha cosine of beta. All right. So this is the expansion. That's the green one. And this is the red one. Okay. Lovely. So let's see here. We had the hunch. We're like, hey, maybe we'll get some cancellations. Who knows? Well, it looks like we have a cosine of alpha sine of beta and a negative cosine of alpha sine of beta. Let me switch back to blue here. Okay, we'll use that as our default of this one. Okay, so now it looks like I've got two of those. So we'd have 2 sine of alpha cosine of beta over cosine of alpha cosine of beta. All right, so this is all multiplication here, right? I can cancel that. Sound effects. And now I have 2 sine of alpha, cosine of alpha. Ooh, sine over cosine of the same angle gives me tangent. So I have 2 tangent of alpha. Look at that. Look at that. So I like to think of this as like an accordion, okay? When whoop, and then whoop, boom. Okay, a little accordion math. I don't believe that's the official term, but perhaps we'll make it that. All right, very good. So have some faith in that. Expand it out, see if we can get some cancellations, and then simplify from there. And be on the lookout again for your changing things to tangent and cotangent, right? When you get sine over cosine or cosine over sine. I love it. All right, we're gonna get into part B here for tangent. Exciting. Actually, you know what? I'm gonna make this a separate video. Sign them both. That's what we're gonna do. So America, freedom, rock and roll. Mr. Hendrickson's coming in here. I'm going to have to strap up.
Are you teaching right now?
Making videos. All right. We'll see you guys in the next video.